With our IKE policy in place, our IKESA policy in place, both policies written, it's time to put the interesting traffic with a crypto access list. This is how we define the traffic that's going to trigger the build. Because if we don't, the default is we're not going to have a build. You can have all the policies you want, but if you don't have some kind of interesting traffic defined, that is the traffic that puts the entire VPN build into operation, then it doesn't matter how many policies you got. So, what is a crypto ACL? That sounds complicated, doesn't it? I thought it was going to be really complicated the first time I heard of it. Ooh, crypto ACL. Well, it's a crypto ACL is simply an extended ACL. That's all it is. It's going to be applied very differently than anything you've seen before. And by the way, a crypto ACL has to be an extended ACL. It cannot be a standard, as we'll see live here in a few minutes. Thing is that the purpose of the crypto ACL depends on whether the ACL is being applied to outbound or inbound traffic. These are very important rules. For outbound traffic, a crypto ACL permit indicates traffic that will be protected by IPsec. A crypto ACL deny applied to outbound traffic indicates traffic that will not get IPsec protection, but it will still be transmitted. And I say it like that because it's so easy. Your mind's eye sees a deny. It's like, okay, that traffic's not going out. We know better. The traffic's still going out. It's not being denied transmission. It's being denied IPsec protection. That's what we're talking about here with a crypto ACL. What about inbound traffic? Well, one purpose and one purpose only, and that's a permit statement. A crypto ACL permit indicates traffic that is expected to be IPsec protected upon arrival. If it isn't, then that traffic is dropped. So two wildly different operations going on, right, between outbound and inbound traffic. We're way past the days of just doing permit and deny traffic. Some important rules there, but what might surprise you is that since there's such a big difference between outbound traffic and inbound traffic with a crypto ACL, but you will not be indicating in or out when you apply a crypto ACL as you would with a regular ACL, as in this example. I did have this in Cisco router font, but when you enlarge that, it really just burns the retina. So I've got it in regular font here for you. And you can see I'm on fast Ethernet interface. I wanted to apply access list 101. So I put IP access group 101, and we know that is not by itself a legal command. You've got in and out, and you have to specify which one of those it is. But when we apply an ACL, a crypto ACL, you're not going to do that. This is actually what happens. When an extended ACL is used as a crypto ACL, each line is read forward for outbound traffic and backward for inbound traffic. And I've got this on the board for you. We'll write it on the routers as well. But on router 1, access list 103, permit IP host 172.12.123.1, host 172.12.123.3. Source destination, we know that it's an extended ACL. We know the syntax. Now, when this is part of a crypto map, the ACL, again, it's read forward for outbound traffic, and it defines interesting traffic. And that VPN is going to go up when traffic sourced from 172.12.123.1 is leaving the interface for 172.12.123.3. It's going to trigger the VPN build, and that traffic will be IPsec protected. So far, so good. But when traffic comes back, the ACL on router 1 is read backwards, where the source is 123, the destination is 123.1. And when the traffic comes in, router 1 is saying, okay, that traffic better be IPsec protected, or I'm going to drop it like a rock. So while the ACL we write is just like the extended ACL we've written everywhere else, well, the operation of it and the application of it is a lot different. So what I'll do is write this ACL on router 1, the one we just discussed, and a mirror image, not an exact copy on router 3, where the one on router 3 is going to be permit IP host 172.12.123.3, host 172.12.123.1. So both routers will then be able to build a VPN with that interesting traffic. Now, on this subject, it's not on the board, but I want to give you a quick little dad lecture here. If you are cutting and pasting a config this big, I understand. It's a big config. It's a long configuration. And nothing against cut and paste. I do it all the time myself. But you got to be super careful if you're doing that with VPNs, because you can't take the config from one router and just put an exact copy of it on the other and have things work the way you think they're going to work. Because if we did that with the config we have here, if we took all of router 1's config and dropped it on router 3, we'd have to change the ACL line. We'd have to change the ACL 103. We would have to change the setting on the key. Remember the pre-shared key? That had a peer address in it. And we had some other things in there that we would have to change, and you'd have to change this ACL. You got to watch it, because if you are cutting and pasting, you need a mirror image on the other router, not an exact copy. So personally, I think it's easier just to go over to router 3 and config it from scratch. If you really hate to type, I understand that. But my point is, you tend to let yourself in for more troubleshooting than you should have to do if you're copying a VPN config from one router to the other and then just trying to catch all the little edits that you have to make. Okay? One more warning, and this is from Cisco and for me, and it's something that we're going to do here as far as permit host. Using the permit host statement in your crypto ACL, that's perfectly fine, but you should be very wary of using permit any in an ACL that's going to serve as a crypto ACL, especially, of course, if you're doing any for both source and destination, because two things end up happening, and both of them are bad. If you put permit any for your crypto ACL on outbound traffic, what's going to happen? Everything's triggering the VPN and everything's getting IPsec protected. So you got way too much traffic being encrypted and then decrypted to the destination. A lot of overhead. You don't really want to do that. Now, inbound, you got some bad things happening there, because you could have incoming control traffic, protocol keep alives, etc., arriving unencrypted, and you've got an ACL on the router that says, hey, I expect everything that comes in this interface to be encrypted. Well, that's not going to happen. And boy, you're going to have not only malfunctioning network services, but you're going to end up with some lost adjacencies likely as well. So again, using permit host in your crypto ACL is fine. Be very, very wary, careful, don't do it actually, of using permit any for source and destination in that extended ACL. Those are the rules of the crypto ACL, and coming up next, we are going to configure it and put those rules into action.